All right. Now, back here, we just barely, I had to make a new one here, so let's, all right, it's already read. We had the definitions. All right, we said a saturated solution holds the maximum amount of solute for a given amount of solvent at a constant temperature. Back to the cereal and milk, we would say that if it's saturated, that the milk is holding exactly the amount of sugar that it can. There would be no sugar piled on the bottom, and it would not hold more if I put it in. It is holding the exact amount. So if I was holding watermelons, pretty much you can only fit one watermelon in each hand. So the maximum amount I can hold is 2 total watermelons. And I usually tell a dumb story about when I worked in the produce department here. So whatever. Anyway, you have 1 watermelon in your left hand, 1 watermelon in your right hand. That would be saturated. You are holding exactly the amount that you can. If someone threw a watermelon at you, but yes, that's kind of how the story goes, the only thing that you can do is either let it go to the floor, or you can catch it, and usually that's what we would do because it would hurt. If we didn't, it would just hit us. We would catch that watermelon, but the other one, well, I can't hold 3, so it would hit the floor. It's a better story when I'm there and you get to see my face. I don't know. All right. Anyway, just remember, saturate's holding what it can at a specific temperature. All right. Let's see, I got to make sure okay. I didn't want to say it wrong like I did a second ago. All right, unsaturated. It's going to be what it sounds like. Holds less solute than a saturated solution. Unsaturated means I am not holding as much as I can. That milk is not holding as much sugar. If I added more sugar to my milk, it would dissolve completely. It would not come out. All right, so saturated, unsaturated, that's great. The next is called a supersaturated. It holds more solute than it should hold at a given temperature. All right, now, here's another one of my awesome drawings. This is how we would make a saturated solution, or a supersaturated. And if any of you have made rock candy, that's what I'm trying to illustrate here. Rock candy is the string, and it has all these crystals of sugar, and whatever flavoring you put on them, it has on it. Now, it came from a supersaturated solution. All right, to cause a supersaturated solution, you take your solvent, in this case we'll just say it's water, and you add your solute, which is sugar again. All right, and we keep adding it till it can't hold anymore. Then, these are fake flames. I know you don't burn your fire or whatever to heat your water, but we add heat to this water and we make it hotter. When water is hotter, it can hold more of our solute. Remember over here, it was at a constant temperature. Now I'm heating it up, it can hold more. So this hot solution is holding a lot of sugar. Now, the key is that I turn off the heat and let it cool down. And it has to cool down undisturbed. All right? I can't put anything in it. I can't do anything to it. It just has to sit there and cool. As long as it's undisturbed, the sugar will stay in solution longer than it should. So now the solvent is holding more solute than it should. It's supersaturated. All right, we get rock candy by throwing a string in there, and then that sugar comes out and it deposits on the string. We pull it out, and voila! There we go. We have our rock candy. We'll make this blue raspberry rock candy just because it sounds good. All right, put a little blue in there. All right, now we're almost out of time on this one, so we'll finish this up in just a second.